In today's video, we'll be setting up a network security monitoring sensor on the dark side of our network while simultaneously having our alerts turn into little rave lights. Alright, so here's an illustration of our problem and what I'm setting out to achieve here. So, on the left we have the modem, probably given to us by our ISP, and of course this is our link to the internet and WAN. So we have a publicly assigned IP address, and our modem connects to a router through a WAN link, or the WAN ports. It assigns a public IP address to a router, and of course the router also has a LAN on the other side of it, being of course your home network. Probably have a wireless LAN, be some hardwired devices, and they're assigned IP addresses through DHCP and converted to public IP address, or the packets are converted to public IP address packets through NAT to be forwarded to the internet and back. Of course, we're recognized on the internet by our public IP address. So NAT converts our packets going from our LAN, our private IPs, to public. Now let's say we have a hacker somewhere, probably met him in a Call of Duty Black Ops 2 lobby. He's got your IP address, and let's say he tries pinging your home Wi-Fi, your home network. So he sends ICMP request to your public IP address. Now, obviously, we want to be able to capture that traffic, or capture all the traffic that is outbound, inbound, and heading to our network. So let's say we have our capturing tool, just, basically hooked up through maybe like a wireless card, through Wi-Fi, or maybe the Ethernet to our router. And it's trying to capture all the packets that are coming into the network, inbound and outbound. Well, it's not going to be able to capture traffic that gets sent to our public network IP address if it doesn't actually get or sent anywhere into our LAN. So say with ICMP, the thing is that most routers, especially if they're ISP routers, they don't support they don't support port mirroring, two, they don't support forwarding ICMP packets. But say there's attempts made to make intrusions on my system, I'm not going to be able to capture any of it or even know of any such activity if my sensor is on the inside of the LAN, if it's on the other side of the router. So unless the packets are routed to my LAN, I have no way of knowing, what's going on outside of it. So that's why I want to place the sensor somewhere here in between the WAN and the NAT. So that way I'll be able to sift the packets going into my WAN interface. So how do we achieve this? Well, we get a network switch, not a Nintendo switch, not the device that your wife's boyfriend lets you play. I'm talking about a switch, and one that supports management and port mirroring. So we'll have the WAN port connected from the modem to a port on the switch, and then another WAN port going from the switch to the WAN port on the modem. Then we have the Raspberry Pi connected also onto the switch, and it's going to be able to monitor these ports while also getting assigned an IP through the wireless interface from within the LAN. So we'll be able to access it from our devices inside of the LAN and see all the traffic that's coming in. Alright, and the switch I'll be using for this build is the NETGEAR GS105E. That's right, the GS105E. This is a managed switch, meaning it supports port mirroring and also it supports VLANs and other good stuff as well. It also has auto denial of service protection and also implements quality of service. And it is plug and play, but it also comes with a configuration. I think you have to make some kind of NETGEAR account and do all this through a NETGEAR front end. I'm not going to be doing any of that in this video. I think, personally, I really hate when that happens, where you have to have some kind of web. But yeah, this one is plug and play as well, and plug and play will work for what we need to be done, since we're not going to be configuring any VLANs or anything like this. So, sets you back about $39.99. So since we want to place the switch right in between the modem and the router, what we're going to do is we're going to go ahead and give the router WAN through the switch. So we're going to take out the WAN cable that goes into a router, obviously from the modem. And we're going to go ahead and plug it into the switch. So this will be WAN port 1. And we're going to pass over the WAN link for the switch back to the router. So we're going to go ahead and plug in another Ethernet cable on another port. and pass in the over Ethernet cable into the WAN port on the router. So once your switch is on, it should configure itself automatically. You'll know if the WAN in and WAN out ports are lit up in green. And most importantly, on the router, you should see that WAN and internet are also up and running as indicated by the lights, green lights on my router. So now our switch is placed in between the modem and the router, so we'll be able to listen in on traffic that goes into our NAT before it gets translated over to our LAN. All right, so now all that's left to do is to plug in our Raspberry Pi or whatever device, maybe you might have like a Linux computer or a server you want to plug in. We're gonna go ahead and plug it in with Ethernet back into our switch. And this way we'll be able to monitor the WAN ports. So for port mirroring, we'll be able to capture all the traffic that goes in from the modem before it hits our NAT. And essentially the Raspberry Pi, of course, has a wireless card as well. So we'll be able to connect through within our LAN into the Raspberry Pi and capture packets on the Ethernet interface. All right, guys, so now we can go ahead and SSH into the wireless interface on our sensor through our LAN. So as you guys can see, we should have an Ethernet interface right here. Of course, this has my public IP address and a wireless interface. So now if we want to listen in on any packet that comes in or out, so we can go ahead and do sudo TCP dump, of course, the interface name, and we can filter it by ICMP, for example, but for now I'm just going to show you guys. I can do a full packet capture. Again, I don't really want to show off my public IP for obvious reasons, but those ICMP packets that we otherwise would not be able to capture because they wouldn't be hitting any devices on their LAN, I'm going to go ahead and actually ping my home network using my phone, obviously on a cellular connection, so it has a different public IP address. Alright, so here's part of my IP. It starts with 174.207. And I'm going to go ahead and ping it through my phone, my home network. And immediately it shows up over here on our sensor. Alright, so now we need to go ahead and write up our snort config. So we'll go into cd etc snorts. Alright, so we should have a local.rules file inside of our rules folder inside of etc snorts. This is how you make the rules. So say we have an alert for ICMP messages, Internet Control Message Protocols messages, like say pings from external networks. So we'll do ICMP any to any. Of course, any is going to be whatever IP address in this case. So any and all ICMP requests will be marked. So we'll do a message ICMP detected. And SID, just make sure it's anywhere above 1 million, and have rev be 1. Next, we also want to update our snort.conf file. So here I got the variables created for different parts of the config. And we actually want to go ahead and also include the rules. This is where the output is going to be as well. This is var log snort alerts, so you can create this directory if it doesn't exist already, and all our alert logs will go into this directory, and we can tail it after and check on alerts this way. And we also need to include our actual rules, so we have defined the rule path as snorts rules, and local.rules is what we named the rules file. So alright, so we went ahead and actually added some more rules. Let me show you guys. Here it is. So of course we got ICMP for if anybody pings our network or does like scans of it, you know, with Nmap, stuff like this. This is probably going to utilize ICMP, so it's worth being detected and making notes of. Of course, also ICMP is a standard protocol used between communication, so I made sure that it would only make alerts if it was returning to my IP address. Then over here we have anything that targets port 80. Obviously, I don't actually have anything running on port 80 currently, but if I were to, then alerts for any kind of HTTP traffic is just a good thing to do, even from a server side or a system and admin perspective. And over here we have SYN floods. This is more obvious if there's an S flag and there's a certain amount of them within a certain amount of time. And then we want to mark that. Same thing with fin attacks and reset attacks. All of these are different kinds of TCP handshake attacks. And they're probably the most prominent when you host stuff on the internet, like that's front facing. So yeah, make rules for any kind of denial of service is very important, or any kind of attacks or floods. And like I said, I have an Arduino plugged in, so I actually wrote a Python script to send Arduino certain serial commands or serial messages anytime one of these alerts are triggered on the snorts and the snort alerts. So it's gonna have every alert string be turned into lowercase, and if there's any matches, then it'll write the appropriate character into serial connection, obviously being the Arduino. And in accordance to this, I have this Arduino code currently actually uploaded to the Arduino itself. So what this will do, if there's any kind of alerts, it's going to light up on the one of the 4 lights on the Arduino breadboard. And again, anytime you make changes to your config file, all you have to do to test it is do sudo snort C or T for test, and then C and your config file path. So just like so, we got no errors, so it's ready to go, and it should show exactly what the rules are. Yeah, like it says 5 snort rules. The 5 ones I wrote have been detected, including ICMP and TCP. 4 TCP, 1 ICMP. So everything looks right, which means we're ready to start snort. So to do that, all we have to do is sudo snorts I and the name of the interface. Anyways, let's go ahead and actually tail the logs now and find some alerts. Get some alerts going. There we have it. Already got some alerts here. Oh, what's that? What's that? What's that? Got an alert over here. Yes, so this is what I got here with the Arduino. This is the blue lights. It's indicative of ICMP attacks. And green is the, oh my god, this thing is so bright. Holy crap. But here's the wiring. You know, all you electrical engineers, you guys can get creative with what kind of alerts you want to create. This is just an idea. Yeah, I pinged my network from my phone again. So I'm getting a bunch of ICMP alerts here, which is normal. And random bots and stuff were like probably curling my page or doing like, I don't know what, some kind of HTTP requests. But the pinging has stopped because the packets I sent have probably all sent by now. But yeah, for all my wannabe electrical engineers, this is exactly how the configuration should be. You should have one wire going to ground, and this can power up all your lights. So you then go from ground to each of the lights, and you have resistors attached in between end of a light bulb and your output string going from the pin on the Arduino, which is programmed. And yeah, this is the entire setup we got here. We have the switch, we have the Pi, and we have the Arduino. Alright everybody, so hopefully this was of use to you guys, maybe in installing your own network security monitoring system, or thinking about how to approach your home network, or just cybersecure networks in general. Now, you know, I was supposed to try to do some SYN attacks, but I keep getting rate limited at this time. I think a lot of it's to do with just like the DOS protection on, you know, different routers set up through ISPs, but feel free to try this on local devices, hopefully within your network, if you're going to be doing DDoSing. But apart from that, I hope you guys enjoyed the video. We got more to come in terms of cybersecurity lessons. Hopefully next time we'll get into coding, so I'll be doing like C videos, how to do secure servers, how to do antiviruses, this kind of stuff. But let me know what you guys want to see next. I haven't done a cybersecurity video in a while. Check out my last one if you haven't already, being the DIY Wi-Fi pineapple. Also very interesting. Also gets into networking. And I know that this video is a bit kind of weird in the sense that we kind of sidetracked with this whole Arduino thing, but I just thought it was a creative idea to have. I just thought it was a cool idea to have something physical to do with, you know, the different alerts we were getting. Because chances are you're not going to be looking at your logs all day, but, you know, a big flashing light in your face, that's definitely going to get your attention. But all my electrical engineering folks, maybe you guys have better ideas for what you want to do for, you know, certain kinds of really high alerts, you know, especially if you are cybersecuring something more important than just your home Wi-Fi. Maybe you have a large sound system you want to hook up to an Arduino or whatever. Hopefully this inspired you in some way. That's going to do it for me. Thank you guys for watching. Make sure to subscribe. I don't normally ask, but I really want to get the 10K subs now. You know, we're on a roll, and I really would appreciate you guys subscribing. It means a lot. So thank you guys. See you next time.
I'm going broke while I just take it and laugh. I be speeding in that foreign with 5-0 on my ass. But